Goal today is to divide these polynomials so that in the future we can continue to use it to solve when we cannot factor and we cannot do the quadratic formula. All right, first thing I want you guys to notice is the example I gave you, is it in proper order?
Yes.
Okay. Is this one in proper order? Okay. What this means right here is I have a degree of 2 and then an exponent of 1 and then the number. That is not missing anything. In the future, we're going to be missing something, and we will fill out those placeholders. And look over here. Your exponent is 1, and then you go to the number. Are we missing anything? No, so we're not going to fill anything out. So here we go, long division. This is what we're dividing by, so we're going to stick it on the outside. And then this guy goes on the inside. I sometimes close off my division so I know I'm done dividing all the way over here. And also, when we get all the way over here, just like you guys told me up on the board, that's when our remainder occurs. So this is a nice clue to you. Okay. Right, here we go. We are only going to concentrate first term to first term. What times 3x will get us to 15x squared? 5x, yes? Now, we are going to match it up to this other like term 5x and put it right here. And then just like you told me on the board, you are going to multiply it all the way through. So here we go. 5x times 3x is 15x squared. Okay, pause right here and look. Do these two match? Then you chose the right number to go right there. If they don't match, then you don't have the right number right there. Okay? Yes. Okay. Keep distributing through. 5x times 3x is 15x squared. 5x times negative 4 is negative 20x. Okay, this is where I recommend the second color, right here. Pick this up and subtract both of these. Subtract the 15x squared, subtract the negative, turn it into a positive. Show it on there. This is the part that I'm telling you, if you take the time, more likely to get that correct. Okay, do you notice how both of these knock out? Okay, and then negative 8x's plus 20x's is 12x's. Okay, and then just like you told me on the board, we're to the bottom, and what did you bring down? The next number, in our term, the next term, so minus 12. Okay, again, you are going to concentrate first term to first term. What times 3x gets you to positive 12x? A positive 4, yes? Okay, put the positive 4 right here. Do you notice it's over the other number? Okay, we are to the end, meaning anything left over will be a remainder. Okay, take the 4 just like we did, and we are going to multiply it and distribute it through. So here we go. 4 times 3x, 12x. Pause right here and look. Are these the same number? Yes, then you have the right number up here. Okay, keep distributing. 4 times 3x is 12x. 4 times negative 4 is negative 16. Okay, right here, take the time and pick up the second color. Right here. Subtract them all. This is the part I'm telling you. Right here, take the time. Subtract and subtract, turning this one to a positive. These should knock out. We do have something left. What do we have left? 4. So I'm going to write it positive 4, just so I can see the positive. Do you see how we're at the end? Okay. This is our remainder. So I'm going to write positive 4, and we are still dividing by 3x minus 4. All right. At this time, I'm going to pause it, and here's some questions. I'll call it a linear factor. That's actually a proper word for it. Let me write that down. When we are dividing by something that says 1x plus or minus a number, Then we can use that synthetic division, which I heard somebody talk about a little bit earlier. Okay, so here's the problem at hand. I want to take 10x cubed minus 6x squared plus 2x minus 6, and I'm going to take a look. Is that in proper order? Check number 1. Check number 2. Am I missing any terms? No. Okay, take a look at your linear factor, x and then a number. Okay, proper order. Are you missing any terms? Okay, first thing I would like for you to do is solve. Okay, what is the 0 for this guy? X minus 1 is positive 1. Good. Okay, that is the number that you're going to use for your synthetic division. So I'm going to put positive 1 into a box. You guys can let me know how familiar this sounds after we get done here. Okay, then we take we have to solve the factor right here. We're going to take our polynomial that we're going to divide, and I'm going to take only the coefficients. So here we go. Positive 10, negative 6, positive 2, negative 6 again. Okay, skip a line. And now we are all officially set up and ready to start it. Does this seem familiar? Kind of seem familiar. Okay. We use this, I would say, 90% of the time. So if this seems familiar, long division, it probably should. Okay, so here we go. We never touch the first term, just like we did previously, so down drops the 10. And now the box is something you multiply with. So 10 times 1 is 10. Okay, and then you add straight down. Negative 6 plus 10 is 4. Okay, use the box and multiply. 4 times 1, positive 4. Okay, add straight down 6. Use the box and multiply. Positive 6. Add straight down, and we get to 0. Okay, so the first thing here is that this is our remainder. First number you get out is your remainder. So we did get out a remainder of 0. This is your number. This is your x. This is your x squared. And so our answer for ours is going to be 10x squared plus 4x and then plus 6. If you are prompted for a remainder, you can totally put in a remainder as well, but you typically won't need it. So at this point, I'm asking you to plug in 2. So basically plug in 2 and see what the output is. So we are going to pretend we do not have our calculators. You are going to set up synthetic division using a 2 for your box. 2 goes into the box. Moving on. And we are going to write down all of our coefficients like normal. So here we go. 4, negative 15, 9, negative 3. Skip a space. Okay, down it goes. Drop the 4. 4 times 2 is 8. Add it straight down. Negative 7. Multiply. Negative 14. Add it straight down. Multiply. Negative 10. Okay, add it straight down. Negative 13. At this point, our goal was not division. Our output is that what seems like the remainder. Okay, so without using straight plug-in, this also works to find the answer for something with a larger input. All right, so here we go. I'm going to stick this guy to the outside. we are all set up, ready to, okay, focus first term to first term. 3x squared times what will get you to 3x cubed? 1x, good. And I'm going to match them all the way over here with this like term, right here. I do not need to write the 1, the 1x. Okay, take the time, and we are going to distribute, distribute, distribute. So here we go, x times 3x squared. 3x cubed, good. Thank you for pausing. X times 2x is 2x squared. X times 9 is 9x. Awesome. This is the point. Take the time, pick up another color. And subtract, subtract, subtract them all. 90% of my students will get this correct if they take the time to subtract. Okay, these should knock out. If they don't knock out, you have the wrong number and go back. Okay, negative 7x squared plus negative x squared is negative 9x squared. Okay, 7x take away 9x is negative 2x. Bring down the next term. Okay, focus. First term to first term. What times 3x squared will get you to negative 9x squared? Negative 3. Okay, notice that we are at the end, so anything after this will be a remainder. Okay, distribute, distribute, distribute. Negative 9x squared. They match. Keep going. Minus 6x. And then minus 27. Okay, take the time, pick up another color. Subtract, subtract, subtract. Okay, I see 4x and plus 28. Okay, 2 reasons I know this is a remainder. Reason number 1, I'm at the end. Reason number 2, you started with the square and this guy is an x. This is lower, so we are done. So here's our remainder. 4x plus 28 and divide it by 3x squared plus 2x plus 9, this giant thing. Okay. Okay, so now that we have gotten through that one, I want to take the time and point out that we had to use long division on this one because we had a quadratic, 3x squared plus 2x plus 9. Okay, on number 4, because our divisor is x minus 3, so therefore we are going to be using synthetic division. All right, so we've already put all those placeholders in there, even though they are not there. And we're going to go ahead and start with our synthetic division. So step number 1 again is that you always solve, and we get x is equal to 3. So go ahead and put 3 into the box. And then we're going to pop all of these coefficients, even all the zeros, straight into here. Okay, so here we go with the coefficients. Positive 1, 0, 0, 0, 0, negative 243. And I'm going to take the time and count them up. 1, 2, 3, 4. 1, 2, 3, 4. Okay, line. We're ready to start. Drop. Multiply. Add. Multiply. Add. Multiply. Seems like it's growing larger, but I'm not concerned since our final number is so large, low, however you want to look at it. Multiply. Multiply, oh, that comes out awfully nice. And our remainder is 0, so it goes remainder, number, x, x squared, x cubed, x to the 4th. So our final answer is going to be 1x to the fourth plus 3x cubed plus 9x squared plus 27x's plus 81 is our number. And you can pause there. If you're prompted, you can list out your remainder is 0 out of this x minus 3. Okay. Most important thing I want to take away from here is if your remainder is 0, it means that this is a factor if I was to factor this guy out. And this is one of our solutions if I was to graph out x to the fifth minus 243. I should see it crossing the x-axis at 3. So that would be something really important right there. Okay. If you can see on the side, I wrote down, I am able to do synthetic on this one because I'm dividing by a linear factor. Okay. And this one I had to use long because we were dividing out by a quadratic. So ultimately, as we finish out today, I want to make sure again that we know our goal is to practice dividing polynomials, but we are going to use it to start solving. If we can't factor, we can't do the quadratic formula, then we use division to see if it is a solution or not, based on if it has a remainder or not. And that is it for today.